We are talking about paleo channel in the GP2 area. We got several people involved in this project for the paleo channel mapping. But first, we need to clarify the definition of the paleo channel because even our co-author confuse the term between the paleo valley, paleo drainage, and the paleo channel. So we work for the CRCDM over 10 years and as a CP 514 5 years. So we got the term definition for the paleo channel working, for example, like this is drainage basin here, and then the primary valley and the inside the valley. So we're talking about this because when you mapping paleo valley, first you have to work out, especially for the regional scale, you need to work out where this drainage is flowing, where they start. So this is very important for our paleo channel mapping here. And the second, we need to work out what the relationship between the different geological domain in this area, GP2 area. So currently we know this area, the oldest rock is like Gawler Craton, the Musgrave, and Kupana province. We thinking this is a basement of this GP2 area Paleovalley mapping. Why we talking about these rocks? Because we need to work out the Paleovalley field, the sediments, where it come from. For example, like heavy minerals, we work out from here. The main source coming from Kupana area, the first stage, and the second stage transport to opposite basin, and the third stage, and then transport Eromanga basin or even the younger Cenozoic basin, and later accumulate along the Euclid basin margin like geoscience. Now, back to the drainage basin. This oldest basin in the GP2 area is Eromanga basin. So you can see from Eromanga basin study area, you can see if the paleo channel over there, existing over there, that should flowing from southwestern part to the northeast because they need flowing to the basin. This is regional scale. This is for the Permian paleo channel. And the second, the younger one, is Eromanga basin. So we know the Eromanga basin margin in this area. If the paleo channel over there, you should think about they're flowing the same direction like Eromanga basin. They're flowing from southwest and to the northeast. But come to the Cenozoic part, different. Because of this paleoclimate control, this channel from this area normally flowing from northeast, jumping to the Euclid basin, southwest. And for the Euclid basin, we got much more detailed information and result compared to other two basins because we studied this so many years. Come to GP2 paleo channel mapping. This paleo channel mapping, currently we got 10 layers of different mapping. For example, like biostratigraphic points and different age of the paleo channel mapping, like polygon, polyline, and what features and drainage divide. All this information, mostly we work on based on the previous publications we did. For example, like a second edition of statewide the paleo channel mapping, first edition 2007, and the second edition 2012. The Adrian Liliana here is involved with this paleo channel mapping. So we just chop out these 10 layers and plus the new paleo channel mapping, 8 layers not existing in the previous result. Was this is a Permian. Why we come from the Permian channel mapping in these layers compared to the 2012 second edition? Because the high resolution gravity data we got. And the tools we use here, mostly the surface tools and the subsurface. For example, when we're working on the VBF, DEM, land side, normally just telling you the features from the surface, but this is not really genetic related to the subsurface. For example, maybe different idea when you work out. So how to work out the subsurface? So work out the subsurface, normally we're using nighttime thermal, mostly from NOAA and ESTER, nighttime thermal. Remember, nighttime thermal. So this will tell you the cooling time on the subsurface. But the resolution is different. NOAA normally is 1.1 kilometers pixel, and ESTER got more high resolutions like 90 meters pixel. This is one example for showing paleochannel tools we used in this area. For example, is VBN. So you only can see some valley over there. If we call this Paleovalley, maybe already formed there over Permian time, existing now, but maybe no record over there, so you cannot work out, oh, this Permian time, or Mesozoic, or Tertiary, we don't know. So we need to work out the sedimentation history in this area, which channel relate to which basin. This is another example for AEM mapping we're using here. So we use some new data from this GP2 project. Also, we use the old data, compare each other, because by the old time, when we're working for the CSLIM, we only got to view the AEM result, but by that time, we don't know this is channel or not. AEM normally just telling you the high conductivity subsurface, but maybe not related to the channel, maybe to the soft regulars, because they just accumulate water over there. And then when you work out that, so we can work out what age of the channel. For example, this is one example from China gold deposit area. So this is from CSLIM, we work with the GA. By that time, we followed local with the company, we found the channel, big channel. But during the interpretation workshop, we a lot of argue. Because the main channel in that area is flowing to the north, this is the Garfield Paleochannel. Garfield Paleochannel, the maximum depth part about 130. But this channel over 200 meters deep. So eventually we put drill holes, we found out this is a Permian. The only 32 meters thick is tertiary. So what does this mean? By the tertiary time, this channel not going through in that area from north to the west. They got one drainage divide over there. So that's very, very important work out the age because of the paleoclimate control. So this is a China gold deposit area, the paleochannel. And later, China gold deposit using this channel water for mining. Come to the Permian. This is new layers. So we mapping. It's a dark blue area you can see from gravity data. This is new gravity data here. And then we can work out this paleochannel that's flowing from southwest to the southeast to the northwest. Because by the Permian time, we got a glacial development over there. So this means from highland, this Gawler Range area, and flowing to the northwest, and then they stop in here. Why stop here? Because of a Kalari force over there. This is a cross section we just using for the new gravity model. This side we got two sections here. This side we using the old interpretation from Klebs and also in 1975. And this part is from this study working out this paleochannel modeling. This is the Permian. And on the top, only thin sections showing Mesozoic. There's no any tertiary. It's not like previous interpretation over here because we got some drill holes control this area. And also we can see this area is very deep. So this is a Margasian trough, not like previous interpretation. Somebody thinking maybe some Cambrian sediment over there, but we just from this new interpretation, we don't think it's any, maybe only Permian sediments over there. For the Mesozoic sediments, paleochannel, we are mostly using nighttime thermal image from ester. So this ester, we just reprocess that compared to the second edition of the statewide paleochannel mapping. This is the 90 meters pixel compared to NOAA. You say this is NOAA, and this part compared to this part is ester. Very, very high resolution compared to NOAA, and we have to emphasize it's nighttime. Why nighttime? You see, this is daytime compared to nighttime. Nighttime going this direction, daytime going this direction. So daytime only showing some features like landslide. Just tell you spectral geology on the surface. After mapping this area, we using the previous data. In this area, we just create several cross-sections. One is, including this area, we call Imana Lagoon area, because this area, a lot of paleochannel, like I mentioned, just a lower range of the paleochannel, jumping to the margin of the eastern Euclid Basin. So in this area, you can, from cross-section, you can find a lot of channel shapes, W shape. Why? Because of the high stand, low stand sedimentation, just showing the water level. If the water level low stand, lot of topographic high over there, so you can find tidal inlet channel. This is very important because over there you can find, we already got some anomaly from uranium and heavy minerals. And also some cross-section in this area cover the whole Gulf paleochannel, and the Anthony paleochannel, and the Kingunia paleochannel. Because of the time, you can find this from our incoming report book. Another important part in this area for the final work, we just pair up about the information from economic geology. So in this area, first maybe you can find channel placer gold or beta placer gold. Beta placer deposit, we already know several beta deposit over there. And the uranium, some anomaly, also here, clay minerals, and also these days, the Anna just put up some rare earth elements within channel. This is a very hot topic these days. And the coal, groundwater, all information we put in the report book. This is one model we're working on the summary from CSLIM project, just showing the paleochannel work related to the economic geology. So this is an example from one cross-section in the Kingunia paleochannel within the GP2 area. So within the one cross-section, you can find uranium anomaly, placer gold anomaly, primary gold anomaly, and the coal. So even groundwater. So within this one section, you can summarize one model for whole paleochannel mineralization mapping or whole paleochannel mineralization knowledge in this area, in the GP2 area. So all the more information you can find from incoming report book. And later, I'd like to discuss with you about your question. Thank you.